Good morning, students. How your study is going on? How your preparation is going on? How you are also watching the videos and writing the notes, right? So now you are here. Today I am going to explain the class 8 standard, that is science topic, chapter number 4, materials of metals and non-metals. I am going to explain that metals and non-metals. How do you get metals? We know the metals: gold, silver, iron, copper, aluminium. These are all what? Metals. Sodium, that is also metals, right? Substances. Where do we get substances? We will get substances that is for metals, and this is for man-made artificial substance, right? Substance, metals like copper, copper wire. You can take copper, aluminium wire. This and all we will get. That is for metals. That copper wires and all we will get materials. That is for metals. Sulfur, sulfur you will get from that. This is a bundle of that. This is for that is man-made constituents of that sulfurs. And sulfur, like that, is the main constituent of acid rain. This is the main constituent of acid rain. Sulfur is more in that acid rain because these are non-metals. Understood? Understood? Now, these are the substances we are taking metals and non-in metals. That is for metals or non-metals. That is for copper wire is getting from the copper wire, aluminium wire, iron. These are all getting metals. And this for non-metals, that is for sulfur. These and all we will get. That is for non-metals. Understood? Now here I am going to explain. That is for first elements. Elements. What do you mean by elements? See, in a substance that cannot be broken into a smaller, into a more simpler substance. Elements is a substance that cannot be broken into a more simpler substance. That is called, that is elements are classified into, these are the four categories: metals, non-metals, metalloids and noble gases. What is the metals? And now we can take the physical properties of metals. First we are taking the metals and non-metals. We are taking that. That is for first one is physical properties of metals. In that one, malleability. Malleability. What do you mean by malleability? So malleability is the process of beating into a small thin sheets. Just to take aluminium foil, when you are putting the food into that and it will get warm only, it kept in the food in a warm only aluminium sheet. That is for foil, aluminium foil. You know that this is one of the thin sheet. If beating with the hammers, or maybe in the factories also they are beating that thick one of that, it making as a thin sheets. That is nothing but malleability. Making as a thin sheet. Thin sheet. That is nothing but malleability. What do you mean by ductility? The process of drawing into a thin wires. Metals are ductility. Here in the malleability, non-metals are non-malleable because they are brittle. They are brittle means it is broken. In the non-metals, if you put into the hammer, it breaks as a small pieces, but not in a thin sheet. We will get. We cannot get in a thin sheet in the non-metals, in the malleability. Understood? So then ductility is the process of drawing into a thin wires. Like metals are ductility. You can see that copper wires, aluminium wires, iron cables, these and all we will get from the wires. We can make from the wires in the, that is from the metals. That is nothing but ductility. And non-metals, non-ductility because they are brittle. Non-metals we cannot make in a thin wire. If you beat into that, if you are trying to make in a wire, but it will brittle. Brittle means it will get break into a small pieces of the ductility in the metals. Understood? It has a non-metals, right? And the third one is electrical conductivity. Electrical conductivity and thermal conductivity. See here. Metals are good conductor of heat and electricity. Metals are just like the copper and aluminum you can take. Metals are good conductor for heat and electricity. They absorb the heat, but it will not get split into that. Maximum heat, if they have a capacity of the heat, they can accept that heat, and that electricity also, it is the conductor of good heat and electricity, because they have free mobile electrical in it. Because free mobile means they move. Mobile means it will move. The electrons are moved from the wire. In the copper wire or aluminum wire, they can move the electricity. Understood? Now, then, in non-metals are poor conductor. Non-metals does not carry conductor of heat, or maybe heat will absorb, maybe, and electricity does not having in the, this one, non-metals, right? And, okay, heat of, that is for poor conductor of heat and electricity. Next one is luster. Luster means shiny. Luster means what? Shiny. It shines. Smooth, soft, that is for shine. Just to take silver, gold, platinum, these and all, that will be shiny, that is for luster. In that luster, metals, you see, metals are lusters are shiny. Just as you take gold, silver, these and all you can take, that is for shining only. This is for luster. In non-metals, no luster. They are rough, but there is no shiny. They do not shine. Just as you take for any non-metal, that is for not shiny, and it has a rough also. It will not get shine also, right? And then the third one is hardness. Metals are hardness, but some metals are soft, like sodium and potassium. Metals are hard, but some metals are very soft. Which one? Sodium and potassium are very soft in there, right? In non-metals, you take the hardness. Non-metals are also soft. Non-metals are get soft, and some hardness of the metals or non-metals are, that is for softness, that we can tell, that is for soft. Which one is? That is for diamond. Diamond is hard, even that soft also. That is a diamond is a non-metal, but it is soft, even that soft also. Understood? This is a hard also, non-metal. Some non-metals are hard and even soft also. Understood? Okay. Next, melting point and boiling point. Melting point and boiling point. In the metals, melting point is very high. Melting points are very high in that metals, and non-metals, that is boiling point, melting point and boiling point are very high. In non-metals, melting point and boiling point are low melting point and low boiling point in the non-metals. In the metals, melting point and boiling point are very high. In non-metals, melting point and boiling point are very low. Understood? Next, I am going to the sonority. Sonority means that is for sound, making the metals are making the sound. Just you take a gold and silver, you shake it, it will get sound also, right? Okay. If you throw on down, it will get sound little bit on that. Sonority, we can produce, we can hit. If we hit, it gets sound. It produces sound, right? If you take metal, iron piece or copper metal, like that, if you take the vessel, you take copper vessel, if you hit on that with a stone or like that, it gets sound. You will get sound, right? That is for sonority. In the metals, sonorous, they produce sound. Metals, they produce sound in a sonority. Non-metals, that is for non-sonorous. They cannot produce sound. They will not produce any sound in the sonority. Like that, physical state. Physical state in the metals. Metals having physical state. So, see, solid at room temperature. When room temperature is there, solid becomes as a solid. Understood? Non-metals, they have non-metals, solid also having, liquid also, and gaseous state also having in that. That is the physical state, that is for non-metals. Understood? Next, I will explain the chemical properties of metals and non-metals. Understood? Now here I am going to explain chemical properties of metals and non-metals. In that chemical properties, reaction in the first one, we are taking reaction with oxygen. Reaction with oxygen with metals and non-metals. Right? See, I will explain here. Reaction with oxygen. Reaction with oxygen or air we can tell. Metals react with, now see the first point. Metals react with oxygen to form metal oxide. When metal is react with oxygen, what it will form? Metal oxide will form. Metal react with oxygen, then we'll get that is for metal oxide. And metal oxides are basic in nature. Metal oxides are basic in nature, remember that. And it turns red litmus paper to, if you keep on the metal red litmus paper, it turns as a blue litmus paper. It turns as a blue litmus paper. Example, you can take here, see, sodium is metal plus oxygen. What it gives? It gives sodium oxide. Sodium oxide. Na sodium plus oxygen. If you have taken O2 is oxygen, and if what it forms? Sodium oxide will form. I told metal react with oxygen, it gives metal oxide. Metal reacts with oxygen, it gives metal oxide. And yeah, we can take metal react with oxygen, it gives metal oxide, magnesium oxide. Magnesium plus oxygen, it forms as a reaction of magnesium oxide will form. Understood? These are the examples we have taken into that is for we can take. And I will give that it is not there in the textbook, some hints are there, I will give you the important point. Some metal oxides are amphoteric, some amphoteric acids. Which one? Reaction with oxygen is which one? They are base in nature. They are in base in nature. And what I told? See here. So I told metal oxides are basic in nature. Basic in nature. Now here you see some metal oxides are amphoteric. Amphoteric means it has acid also base also. Acid also and base also. It has base and acid also. Their both characters are present in that. Both characters are present in that. Both characters are present in that. That is what? Amphoteric acid. Amphoteric. Right? Some metals having, I told, if you take Al2O2 and Al2O3, then plus of HCl, you see here hydrochloric acid. This is in acidic in nature I am taking. Now in place of what we will take, aluminum chloride will form Al2Cl plus what we will get H2 here. H2 will be there. That is for what we will get H2O. H2, this is for 3, chloride will get 3 here and H2 will get, water will forms. This is for acidic in nature. I told you aluminum chloride plus water will forms. Similarly, if you take with the base, this is the base. Al2O3 plus NaOH. If what it will form? Sodium aluminate will form. Sodium aluminate will form. See, NaAl2 and plus H2O. This is water will forms. Here H2, here we are taking H2O we will get. That is for sodium aluminate. This is forms sodium aluminate plus water will get. That is what it is in. This is acid and this is base. This is the that I told that is for amphoteric acids. Some elements some metals are there, that is what they have acid also and some base also. Understood? Now next I am going to explain here. Some metals react with oxygen to form metal oxide and nature in that is for blue litmus to red litmus, and some non-metals are neutral. I told that one. And next I am going to explain with that. Now I am going to explain the second one, reaction with water. Reaction with water. Metals react with water. How? Metals and non-metals also. See, I will explain here. When metals react with water, forming metal hydroxide. When metals react with in the previous one, in the first one with oxygen, what we are taken, metal oxide will form. Here they are reacting with water. Metal react with metal oxide. Metal react with water. What it will form? A metal hydroxide will form, and hydrogen gas is released. And some react with cold water. Some react with cold water, and some metals react with hot water. Right? Metals react with cold water and hot water also. Now I can tell you explain the example also. I can take this part. In that, metal react with, so if I take that example, see, sodium react with water. Sodium react with water. H2. What it is give? What it give? NaOH. NaOH will form. Sodium hydroxide will form. Sodium hydroxide will form, and H2 gas will evaporate. H2 gas will release. Right? Understood? Okay. We can take calcium plus water. If you take that reaction, calcium oxide will form. CaOH. CaOH2. Calcium hydroxide will form. Calcium hydroxide will form. Plus H2 gas will evaporate. H2 gas will release. So here we are taken, when metals react with water, sodium hydroxide solution will get, that is metal will get, and hydrogen gas will release. And similarly, calcium plus water we are taken, that react with, what is the reaction should be given? Calcium hydroxide will be given. I told you metal hydroxide will give. When metal react with water, what it will give? That metal hydroxide will give, and hydrogen gas will release. Hydrogen gas will release from that. Understood? So some react with steam, and some do not react with steam. Some do not react. Though here non-metals do not react with water. Non-metals do not react with water. Remember that point. Sometimes they will ask, when non-metals react, whether non-metals are react with water or no. Yes. You have to write no. Right? Because they need to supply the displays of hydrogen, and for displacing they need to donate the electrons of hydrogen, electrons to hydrogen, but it is not possible. They are themselves electrons acceptor. But we are sharing the electrons, they are acceptors, but they do not share the electrons. Understood? Next, I am going to explain the we'll see. Now here, the third part, reaction with acids. The third one is reaction with acids. See here. Metals react with acid to form salt, and hydrogen gas will release. Salt also he will give, and if you react with acid, metals react with acid, it gives salt, and hydrogen gas will release similarly. And example I will tell. See here, zinc is metal, and plus HCl, hydrochloric acid. This is acid. I told no. Acids. Zinc plus HCl. What it will give? Zinc chloride will form. Zinc chloride Cl2 will form, and plus hydrogen gas will evaporate and release the hydrogen gas. Zinc plus HCl, that is Cl will get. Zinc plus Cl will get Cl2, that is zinc chloride will form, and the hydrogen gas will release. This is a salt, and gas will release. The hydrogen gas is hydrogen gas. Hydrogen gas will release from there. Similarly, you take magnesium, see, Mg plus HNO3. Right? It gives what? Magnesium nitrate. NO3. MgNO3 two times, and plus hydrogen gas will release. Hydrogen gas will release. That is also will get salt. This is also we got said, and hydrogen gas will evaporate and it will listen. Metals given below is a reactivity series in the can't display. Hydrogen is a acid, hydrogen of acid. Zn Zn plus we can take Zn plus H2SO4 H2SO4 sulfuric acids. We can take a dilute sulfuric acid. For concentrated sulfuric acid we are taken. What it will form? Zinc sulfate will form SO4 and plus hydrogen gas will release. Hydrogen gas will release up. Right? That is for zinc sulfate will form. That is for salt here. That is for zinc sulfate solution will be formed. So then, and that hydrogen gas will evaporate. And this we got. This is for the metals through through the reaction of metals with acids, right? And one more important thing, non-metals do not react with as they can't display hydrogen from acid. Reasons: non-metals do not react with dilute acids or acids. As to react, they need to display hydrogen, and to displaying, they need to donate electrons to hydrogen. But it is not possible. They are themselves electron acceptors. They are only electron acceptors. That's why the non-metals does not react with acids. Understood?